In this lesson, we're going to classify functions as being either even, odd, or neither. So any function that you see, any function, whether it's algebraic or whether a graph is given, you can determine if it's considered an even function or an odd function or neither. Now, when we say the word neither, we mean neither even nor odd. So it's neither an even function nor an odd function. That's what that neither means. Okay, so if you look at this example here, now this example right here, where we have f of x equal x squared minus 4, so we have this function. And remember, whenever we're talking about even, odd, or neither, we are talking about functions. So first of all, it has to be a function. And so in this case, this right here is considered an even function. All right, now let's discuss why this is an even function. Let's talk about symmetry. So this whole idea is dealing with symmetry. So what can you tell me about the symmetry of this quadratic function? Now this quadratic, you all know about quadratic functions. You know the graph is a parabola. But tell me something about the symmetry. And so if you look at the vertex, remember the this y-axis here? This y-axis divides the parabola into two parts. And so in terms of symmetry, if I were to take this part right here and reflect it, kind of fold it over like this and reflect it about the y-axis, then I would get this part. Okay, so an even function, remember this is an even function, so an even function, an even function is a function whose graph is symmetric about the y-axis. So it has y-axis symmetry. So basically y-axis symmetry. Okay? So what I want to do though is also talk about some points. Let's look at some points on this graph. Okay, so I want to look at this point here. Let's say the point right here, this point here, and let's say that's the point 3, 5. Okay? And if I were to reflect that point about the y-axis, and so remember, I want you to also look at this. When we talk about y-axis symmetry, remember this this distance right here from the y-axis to this point, that distance here is the same as that distance. Okay, so this distance is the same as that distance. So if you can look at some more points, it doesn't matter which point you look at on the parabola, this distance is the same as that distance. That distance, same as that distance. So meaning that if you were to take each of these points right here, reflected about the y-axis, you would get that point here. Take this point, reflected about the y-axis, it will be a point on this line. On this part of the graph. Reflected, you get this point. So I want to look at this point, and so for reflected, you agree I'll get this point, right? Well, look at the coordinates of that point. So the coordinates of that point is -3, 5. Okay, so let's look at a couple more. So if I take, let's say, the point 2, 0 right here. That would probably be a bad one to use anyway, but let's just still use it. 2, 0. If I reflect it about the y-axis, you agree I get -2, 0, correct? All right, let's look at this point here. 1, -3. If I reflect it, remember the distances are the same, so this distance same as that distance. So if I reflect it about the y-axis, I get this point here, and the coordinates of that point is -1, -3. So I want you to look at these points. So if we're talking about an even function, and the point 3, 5 is on the graph of an even function, then what other point better be on that graph? Well, -3, 5. If the point 2, 0 is on the graph of an even function, then what other point better be on it? -2, 0. If the point 1, -3 is on the graph of an even function, then the point -1, -3 will also be on it. So I want you to look at these y coordinates. So the y coordinates, when I reflected about the y-axis, the y coordinates stay the same, right? It kind of has to because it's still horizontal to each other. You agree? So it's these points here, they're horizontal to each other. So this y value is the same as this y value. This y value, same as this y value, and so on. What changed, though, is the x-coordinate. How did the x-coordinate change? Well, the distance from, remember, this is the origin right here. So the distance from the y-axis to this point on the right is 3 units, and if I go this way, you're going in negative 3 units, right? So the x-coordinates for an even function, the x-coordinates are going to be opposites of each other. So notice 3, negative 3, 2, negative 2, and negative 1, negative 1. Okay? So this is going to be important in a little while when we talk about the algebraic test. All right, so that's an even function. So we all know that an even function, the graph is symmetric about the y-axis. Now let's look at an odd function real quick. So here's an odd function right here. So this is an odd function. And so notice, now this is a little bit harder to discuss. So I'm going to do it this way. So first of all, do y'all agree that this graph is not an even function, right? Because in an even function, it would have to be symmetric about the y-axis. So you know it's not an even function. Okay, so let's talk about, well, is it an odd function? Well, let's see what an odd function is. So here's an odd function. So this is an odd function. I'll tell you this right now. So that's an odd function. And it kind of, if you look at the exponent, the only exponent you see is 3, and that's an odd function, right? And well, that's an odd number, I should say. So what you want to think about is this. So that's an odd function. Now, if I look at the origin right here, see this origin right here? And if I look at this point right here, okay? And let me go ahead and start here. So actually, let me do this. I'm going to do this. So I'm going to use this piece of paper, and here's the origin. I'm going to put the corner right here at that point right here. And I am going to connect it through the origin like this. And so I have this. So this distance from here to here is that distance. If I take this corner now, put it at the origin like this, that dot right here is now, I'm going to go ahead and move it up a little. That dot right here is now this. Well, so this point here, right here, that point here was 2, 8. So if I reflect this point about the origin, so if I take this point right here, so you have to kind of visualize this. So if I take this point here, and here's the origin, so I'm putting my ruler in the origin. So if I take this point reflected about the origin, that same distance through the origin, okay, on the other side, that same distance on the other side, I get this point here. And if I do the same thing with, let's say, this point here, reflected through the origin, look carefully. It's kind of difficult to understand. Look carefully. So if I take this point here, that's the point 1, 1, reflected through the origin, see that distance? Go the same distance, I get this point right here. And that's the point negative 1, negative 1. And so if you look at this point here, that was 2, 8, and I reflected about the origin, I get the point negative 2, negative 8, right? If I take the point 1, 1, reflected about the origin, I get the point negative 1, negative 1. So I want you to compare those coordinates. So 2, 8 became what? When I reflected by the origin, becomes what point? Negative 2, negative 8. How did it change? Well, the x-coordinates became opposites, and the y-coordinates became opposites, right? And then 1, 1, how did that change? Became negative 1, negative 1. So the x-coordinates are opposites, and the y-coordinates are opposites. So the point's this. If the point 2, 8 is on the graph of an odd function, then the point negative 2, negative 8 will also be on it. If the point 1, 1 is on the graph of an odd function, then the point negative 1, negative 1 will also be on it. All right, so an odd function is symmetric about the origin. So if I take this point here, see this point here, whatever that may be, and I reflect it about the origin, see this right here? Okay, so that distance right here, that distance will become, that distance here is the same as this distance right here. So you get that point. All right, so whatever this is, this becomes that. And sorry you couldn't see it, but basically what I was saying was this, that this point here, if I reflected about the origin, it helps if you kind of use a ruler. Take this point, go through the origin, that distance, go the same distance, you get that point here. And it turns out that you see how it's in the first quadrant, they're positive coordinates. When you reflect by the origin, they become negative coordinates, so they become opposites. Okay. All right. So it's a little bit harder to see the odd function, but an odd function is a function whose graph is symmetric about the origin. Okay, and so it's symmetric about the origin. Okay, now, so basically we said this. Now this is important in terms of points. I want you to remember this. So if a point -3, 2 is on the graph of an even function, then what other point better be on it? So remember the y coordinates stay the same. What changed? The x coordinates became opposites. So the point 3, 2 is also on it. Okay? If a point -3, 2 is on the graph of an odd function, then what other point better be on it? Remember, that's where we take the opposite. So you're going through the origin. Okay, we're going through the origin. So any point in the first quadrant goes in the second quadrant. Any point in the the third quadrant. Any point in the second quadrant goes into the fourth quadrant. Okay, so basically the signs change. So the coordinates become opposites. So then the point 3, -2 is on the graph. Okay? All right, so that's going to be important to remember. Okay, now let's look at this idea. So I have this graph here. So I have this graph here, which is a quadratic function. And here's my question. Is this function an even function? Well, remember, it's an even function if it's symmetric about the y-axis. Is this function symmetric about the y-axis? No. It's not symmetric about the y-axis. Is it symmetric about the origin? No. So if this is the point of the graph, then you better have a point down on this side, right? So it's not symmetric about the origin, so it's not an odd function either. So remember, if it's not an even function and it's not an odd function, we say neither. So this is neither. Okay, so neither odd nor even. Okay? All right, so that's what we mean by the idea of neither. Okay, now let's look at this. So look at this line right here. Is this horizontal line an even function, an odd function, or neither? Well, let's look at the point. So this point here is 2, 5, right? So if you look over here, is -2, 5 on there? Yeah. So this is an even function. So if you take this side, reflected about the y-axis, you get that side here. So no matter what point you pick on this side, you reflect, you're going to get a point on that side. So this point here is -2, 5. So this is an even function. That's an even function. Over here, if you look at this, what do you think this is? All right, you know it's not even because it's not symmetric about the y-axis. But is it symmetric about the origin? Sure it is. So if I look at this point here, the point 3, 3, then what other point better be on that graph? Well, if it's symmetrical about the origin, then the point -3, -3, that's where both coordinates should take the opposites. So -3, -3, right? And here it is right here. See this point right here? 2, 2. Then what other point better be on it? Well, -2, -2, and here it is right here. So that's an odd function. So that graph is symmetric about the origin. So an odd function is symmetric about the origin. Over here, you think this is even, odd, or neither? It's even. I didn't draw it very well, but it's even. So this point here, if I reflect it, I get that point here. This point here, if I reflect it, I get that point here. This point here, if I reflect it, I get that point here. So that's an even function. Okay? Now, look at this one. Right away, many of you are going to say this is an odd function, because if I take this point reflected about the origin, I get that point. If I take this point reflected by the origin, I get that point. This point reflected by the origin, I get that point. But it is not odd. It is not odd, it's not even, it's neither. You may say, well, why is it not odd? It looks odd. Well, here's why. Okay, so if I take this point here, okay, reflected about the origin, so this is a point 6, 0. If I reflected about the origin, remember the signs, the coordinate become opposites. So this becomes -6, 0, which is this. I agree. You're right. That is true. If I look at this point here, that's the point -3, 2. So now I didn't draw it very well, but if I reflect that about the origin, it becomes the point 3, -2, which is right here. Okay, so that's 3, -2. So you may say, well, why is it not an odd function? I mean, an odd function. Why is it not symmetrical about the origin? Because of this. Look this right here. This is the point. Now, this is kind of tricky, but you may see something like this in some of your problems. This is a point -4, 0. Okay? -4, I'm sorry, excuse me, 0, -4. That's the point 0, -4. If I reflect that point about the origin, I get the point 0, 4. You may say, well, that's 0, 4, but here's the thing. See, that's an open circle. That's an open circle. An open circle is not part of the graph. So remember, in order for it to be an odd function, in order for you to have an odd or even function, every point on the graph has to also be on the graph as well. So if the point 0, -4 is on the graph, then the point 0, 4 better be on it, and it's not, because that's an open circle. Okay, so this is neither odd nor even. So that one was tricky because of that open circle right there. Okay? All right, now let's talk about the algebraic test. So there's an algebraic test you can use to determine whether an equation, whether a function is even, odd, or neither. All right, so to talk about that algebraic test, we need to talk about this. Okay, so do y'all agree that's an even function, right? You can even tell that if you take this part of the graph reflected about the y-axis, get this part. So yes, that's an even function. Now, remember what we said earlier. This point here, let's get this point right here. Now, it's not numbered. I meant that to be not numbered at all. But if I take this point here, reflected about the y-axis, I'll get this point here, right? If I take this point here, reflected about the y-axis, I'll get that point, and so on. So it's an even function. All right, now what I want to do is this. Okay, so I'm going to label this point right here that we just discussed. I don't know what number that is, so I'm just going to call it x. So call this x, okay? And so the distance from here to here we'll call x, and then I want you to notice something. This point here, right here, if I look at this right here, so if this is x, then this is what? Negative x, right? That'll be negative x. So for example, this is 5, this is -5, okay? And I'm going to label this point here y, okay? So I'm going to label this y. And remember, we are talking about a function, so I can also call this, well, I'm going to deal with this after a while. All right, so I'm going to call this point here x, y. I'm going to call this point here -x, y. Y'all agree? Y'all agree with that, right? The y values have to be the same. So y, y. This is x, this is negative x. And it kind of made sense based on our discussion earlier that if xy is on the graph of an even function, then negative xy better be on the graph as well. All right? Now here's what I want to talk about. And I want to talk about this in terms of function notation, f of x. So this is the graph f of x here. Okay? So if, remember, f of x means the same thing as y. All right? So I'm going to replace this here with x. Remember, y means the same thing as f of x. Okay? And over here, I'm going to replace y. Now be careful because I'm going to use this for my x. So this will be y equals f of negative x. Okay? So what I want you to notice is that, remember, the y values are the same, right? The y values are the same. So what that means is this. What that means is this, that f of negative x, this y value and this y value are the same. So f of negative x has to equal f of x. Okay? So f of negative x has to equal f of x. So here's what I need to remember about this. All right. A function is even if f of negative x is the same as f of x. Kind of makes sense, right? So meaning that those two y values are the same. Those two y values are the same. So this is x, and I reflected about the y-axis, I get negative x. And those y values have to be the same. So that's what that means right here. Okay? So a function is even if f of negative x equals f of x. All right, now let's look at an odd function. So this is an odd function right here. Now remember when we talked about an odd function. So if I take this point here, right here, reflected about the origin, I'm going to get this point here. Y'all agree? And remember, if I call this right here x, and this right here y, then that's the point xy. Y'all agree? Okay? And this point here would become, so this is x, this is going to be what? Negative x. And this will be not y, but what is this? Negative y, right? So this will be the point negative x, negative y. Kind of makes sense because remember we talked about an odd function. If xy is on the graph of an odd function, then its opposite for both coordinates are going to be on it as well. Okay? But I want to look at this in terms of function notation. Okay, so this is where we have to be a little bit careful how we discuss this. All right, so do y'all agree? And I'm going to do this first. Okay, so see this one right here? I'm going to rewrite this as x f of x. Y'all agree that's true, right? Because y, same thing as f of x. So x f of x. Now let's go talk about this right here. So if this is negative x, then this right here, okay, I'm going to write this as negative y. Okay, so if this right here is negative x, then this becomes f of negative x. Y'all agree? Okay, and remember this right here means this. Okay. All right, so we have this. We have f of negative x means negative y. Okay? Well, isn't y the same thing as f of x? So this right here becomes, watch this, negative f of x. So what we're saying is this now. We're saying that a function is odd if f of negative x equals, negative x, if f of negative x, if f of negative x equals the opposite of f of x. Okay, so that's what that means. So f of negative x equals the opposite of f of x. For an even function, look at this. F of negative x equals to f of x. Even function, f of negative x equals to f of x. Odd function, f of negative x equals to the opposite of f of x. Okay? So what that means here is that the y values are the same. Okay? What that means here is that the y values are opposites of each other. Kind of makes sense because look, tell me something about these y values here. This y value and this y value are opposites, right? That's what this is saying. This is saying that the y values are opposites of each other. Okay? That's what that's saying. Okay, now, so let's go back to that original page we had. So the original page, meaning that first page we talked about where we had functions, whether that's even, odd, or neither. And I want to put this as well now. So I'm going to put this at the bottom. It's going to be important. So this is the test algebraically to determine if a function is even, odd, or neither. Okay? All right. So this is what we know. We know that a function is even if f of negative x equals f of x. So meaning that the y values are the same. Kind of makes sense. Remember even functions were symmetrical about the y-axis, right? So it made sense to think like that, right? So a function is odd if f of negative x is equal to the opposite of f of x. Okay? And if none of this is true, then we say neither. Okay? So here's what you do. First thing you're going to do is you will plug in negative x in place of x and then work algebraically. Okay, and see what you get. All right, and see what you get. All right, so let's get some examples. All right, so the directions will say something like this. Determine algebraically if the function is even, odd, or neither. Even, odd, or neither. Okay? All right, so let's do the first one. So here's number one. F of x is equal to 6x to the 7th plus 2x cubed. 6x to the 7th plus 2x cubed. All right, so the idea is this. You're going to find out what f of negative x is. Okay, what is f of negative x? So find f of negative x. So that's the idea. So let's find f of negative x. So where we see the variable x, you're going to substitute negative x. All right, so here's what we get. We get 6 times negative x to the 7th plus 2 times negative x cubed. That's what we get so far. Okay? Now remember this. A negative x raised to the 7th power, okay, negative x raised to the 7th power means this. It means negative x to the 7th. That's what that is. Okay? Those two are the same thing. Because remember, that means negative x to the 7th means negative x times negative x times negative x, so on. 7 times. A factor of 7 times. So that's going to be that. Okay? So this becomes this. 6 times a negative x to the 7th plus 2 times, and then negative x cubed, negative x cubed. So a negative number raised to an odd power is negative. X cubed is x cubed. So this is 2 times a negative x cubed. And so I get this. 6 times a negative x to the 7th is a negative 6x to the 7th. 2 times a negative x cubed is a negative 2x cubed. All right, so that's what f of negative x equals. Okay? Now, here's the thing. Here's the thing. Is f of negative x, is f of negative x the same as f of x? So basically, so you're asking yourself this. Is f of negative x equal to f of x? All right, remember, f of negative x is this, right? So here's the question. Is this right here, which is negative 6x to the 7th minus 2x cubed, the same as f of x? And here's f of x. Are those the same? Yes or no? No, they're not the same. This is negative 6x to the 7th. This is a positive 6x to the 7th. This is a negative 2x cubed. This is a positive 2x cubed. So they're not the same, right? So f of x is not an even function. So that means that f of x is not even. All right, well, let's check odd. Let's see if it's odd. So here's the question. This was is f of negative x equal to the opposite of f of x? That's the question. Is f of negative x equal to the opposite of f of x? All right, well, here's f of negative x. We found it right here, right? That's this. And here's the opposite of f of x. F of x, remember, it was this. And here's the question. Are these the same? Yes. Because if I distribute, I get negative 6 to the 7th minus 2x cubed. So those are the same. So yes. So that means that f of x, which equals 6x to the 7th plus 2x cubed, is an odd function. Is an odd function. Okay, which means that it is symmetrical about the origin. All right, so that's what you're going to do. So that's how you do that. So you just go through those thought processes. All right, go through those two thought processes. All right, let's do another one, number 2. Okay, so let's do number 2. So number 2, let's suppose we had this. Let's suppose we had f of x equal x to the 4th minus 2x squared plus 7. So x to the 4th minus 2x squared plus 7. All right, so notice that when we looked at algebraically, we looked at both f of negative x. All right, so we got to find this first. We got to find f of negative x, and then we'll compare this side. All right, so let's find f of negative x. So f of negative x will equal, where we see the variable x, I substitute negative x. So negative x to the 4th minus 2 times negative x squared plus 7. Okay? Now, what's a negative x times itself 4 times? Well, remember, negative raised to an even power is always positive. So y'all agree that that's going to be x to the 4th? And what is negative x squared? Well, that's x squared, right? So that becomes minus 2x squared. So this right here is this, plus 7. So what we found is this, f of negative x equal x to the 4th minus 2x squared plus 7. What do you notice about this? You notice, don't you see that f of negative x, which is this, so you can compare f of negative x is f of negative x equal to f of x? Yes, because isn't this right here this? And so f of negative x, which is this, those two are equal. So f of negative x is this, f of x is the same thing, isn't it? So they're equal to each other. So this right here is the same as this. So that means that f of negative x is equal to f of x. All right, so now f of x, which is this, is an even function, which means it's symmetrical about the y-axis. It's symmetrical about the y-axis. Okay, all right, let's do number 3. So number 3, let's suppose we had this. Let's suppose we had 3x equal, I'm sorry, 1. So number 3, excuse me. F of x equal, let's say, 2x minus the absolute value of 2x. 2x minus the absolute value of 2x. Okay? So again, we're going to find f of negative x. So where we see the variable x, I'm going to substitute negative x. All right, now don't get too confused about the absolute value here. It's not that bad. So I'm going to get 2 times the negative x minus the absolute value of 2 times the negative x, right? Okay? All right. Now, here's what I want you to think about. So this right here becomes negative 2x. That's easy to see, correct? All right. And regardless, and you see this right here, 2 times the negative x? Y'all agree that means the same thing as negative 2x, right? Negative 2x. Regardless of what x is, whatever is inside that expression, is it ever going to be negative? No. So this, so if x is some real number, either this expression will be positive or 0. So I'm going to write this as just the absolute value of 2x. So that's what the same as. So this will be the same as that. Okay? But you got to keep the absolute value bar, though. You can't throw it away. So the absolute value of negative 2x is the same as the absolute value of 2x. Kind of makes sense because you got to think about this. If x is 3, what's 3 times a negative 2? Negative 6. What's the absolute value of negative 6? 6. If x is 3, what's 3 times 2? Positive 6. What's the absolute value of positive 6? 6. So they're equal to each other. Okay? Now compare this with this. Compare what you end up with. See, this is f of negative x. Is this the same as this? No. Because this is a 2x, this is negative 2x. Are they opposites? Is every term here the opposite of this? No. These are opposites, but are these opposites? No. So f of negative x does not equal f of x, right? Those two are not equal. F of negative x is not the opposite of f of x. So what do we say? So it's neither even nor odd. So what do we say? Neither. So f of x is neither even nor odd. Okay? All right, so it wasn't very important that you see this, though, that the absolute value of negative 2x is the same thing as saying the absolute value of 2x. Because look, if x is negative 5, what's a negative 5 times a negative 2? 10. What's the absolute value of 10? 10. What's negative 5 times 2? Negative 10. What's the absolute value of negative 10? 10. So those two will be equal. All right, so I need you to understand that those two are equal. Okay? All right, number 4. So number 4, let's suppose we had this. Number 4. Suppose we had f of x equal 2x times the square root of 7 minus x squared. 2x times the square root of 7 minus x squared. All right, so again, first thing we always have to do is find f of negative x. So if what I get here is the same as this, it's even. If what I get here is the opposite of this, it's odd, right? Okay. And if there's no comparison, we say neither. So where we see the variable x, I substitute negative x. So notice I see x twice, right? So you got to be careful. So you got to say 2 times negative x, just like this, times the square root of 7 minus x, which becomes negative x squared. Now this looks pretty messy, doesn't it? It looks like I don't know what to do, right? Okay, well, cover this part up and ask yourself, what's 2 times a negative x? Well, that's a negative 2x. Square root. Now, look at this right here. See that negative x in parentheses squared? What's a negative x in parentheses squared the same as? X squared. So this becomes 7 minus x squared. Okay? Now here's the question. Just ask yourself, so this is f of negative x. Is this the same as this? Does that look exactly the same as this? No. Okay? Now you ask yourself this. Is this right here the opposite of this? Yes. This is a positive 2x square root of 7 minus x squared. This is a what? Negative 2x. So what I'm square root of 7 minus x squared. So what I want you to understand is this. You see this right here? Look, this right here. This piece right here, this piece that I'm boxing off, I'm going to cover this up. Isn't this that? So this piece right here is f of x, right? But what is in front of it? Negative. So that means that f of negative x is the opposite of f of x. That means that the y coordinates are opposites. Okay, so that's negative x right here. All right, so therefore f of x is an odd function. So f of x is an odd function. So it's going to be symmetrical about the origin. So it's symmetrical about the origin. Okay? All right, number 5. Okay, let's suppose number 5, we have this. All right, let's say this number 5. F of x equal negative 5 x to the 5th minus 3x cubed. Negative 5 x to the 5th minus 3x cubed. Okay, so again, let's find f of negative x. So we see the variable x, I'm going to substitute negative 5, so you get negative 5 times the negative x to the 5th minus 3 times the negative x cubed. Notice that in place of x, I'm substituting negative x. The parentheses are important. Make sure you remember the parentheses are important. Now what you got to do is go off to the side and kind of figure out, well, what is this right here? What is this? That's what you got to figure out. Okay, so remember, negative x to the 5th means what? Means negative x to the 5th without parentheses. And negative x cubed, remember, a negative number raised to an odd power is always negative, right? A negative number raised to an odd power is always negative. So that's going to be a negative x cubed. So I'm going to rewrite this as negative 5 times a negative x to the 5th minus 3 times a negative x cubed. Okay, so that's this, that's this. A negative times a negative is a positive, so this becomes 5x to the 5th, right? A negative times a negative is a positive, plus 3x cubed. Okay? Now here's my question. Now remember, this is f of negative x. So my question is this: is f of x even? Well, here's f of negative x. F of x is an even function if these two are the same, or these two the same. No. But then you ask yourself this now: is f of x an odd function? It's an odd function if every term is the opposite of each other. So you see a negative 5x to the 5th, what do you see here? 5x to the 5th. You see a negative 3x cubed, what do you see here? A positive 3x cubed. So algebraically, if you want to make it look like what we did here, here's what you would do. Okay, so you see this right here? Okay, this right here? So what I'm going to do is this. So we know that those are opposites, right? So that means this, that if I factor out a negative 1 from here, just like this, I get negative 5x to the 5th minus 3x cubed. If I take out a negative 1, right? Now look, if I cover this up right here, now y'all agree that those two are the same, right? Because if I distribute, I get this back. So if I cover this part up, isn't this this? So this piece right here is f of x, right? But what's in front of this? Right here. And so what I found is this, that f of negative x is the opposite of f of x. So that means that f of x, which equaled negative 5x to the 5th minus 3x cubed, is an odd function. That's what I just found. So it is symmetrical about the origin. Okay? All right, let's do number 6. Okay, number 6, let's suppose we had this. Let's suppose we had f of x is equal to let's just say 22 divided by x to the 4th. 22 divided by x to the 4th. All right, well, let's see what that is. So we want to determine, is this an even function, an odd function, or neither? That's what we want to know. So we got to find f of negative x. So where you see the variable x, I substitute negative x. So I get 22 divided by, in parentheses, a negative x to the 4th. Let's go off to the side and figure out what this is. You got to go off to the side. So you got to ask yourself, what's a negative x to the 4th? Well, a negative raised to an even power is always positive, correct? And x to the 4th is x to the 4th. So this is just x to the 4th. So this right here becomes this. This right here becomes 22 over x to the 4th. So f of negative x, so f of negative x is equal to this. What do you notice about these two? They're the same. So what we found is this. F of negative x is the same as what? F of x. So what kind of function is f of x then? If those two are equal, if this and this are equal, then that means that f of x is an even function. So therefore, f of x, which equals 22 divided by x to the fourth, is an even function, which means it's symmetrical about the y-axis. Symmetrical about y-axis. All right, this is number 7. Number 7, let's suppose we had this. Let's suppose we had f of x is equal to the square root of x to the fourth plus 8. Square root of x to the fourth plus 8. All right, let's see what that is. So I want to see, is this going to be an even function, an odd function, or neither? Well, let's find f of negative x. So you got to find f of negative x. Notice in every case we had to find f of negative x, in every case. So wherever I see the variable x, I'm going to see it here, I'm going to substitute negative x. So I get this, the square root of negative x to the fourth power plus 8. And we already talked about negative x to the fourth power, right? What's negative x to the fourth power the same as x to the fourth? So this right here becomes the square root of x to the fourth plus 8. So what do you notice about, now remember this is f of negative x. So what do you notice about f of negative x and f of x? What do you notice about those two? They're the same. This is f of x. So those two are equal. So f of negative x does equal f of x. So that means that this function, the original function, so this means that f of x is an even function. So that means that if you were to graph this, it would be symmetrical about the y-axis. Symmetry about the y-axis. Okay? All right, what about number 8? Number 8. So let's suppose number 8, we had this. We had f of x is let's say 7 times the fifth root of x. 7 times the fifth root of x. Okay. Well, if I want to determine if this function is even, odd, or neither, then I need to find out what f of negative x is, and then compare that with f of x. So if this and this are the same, it's even. If this and this are opposite of each other, then it's odd. If there's no comparison, then we say neither, right? Okay, so I get this. I get 7 times the fifth root of a negative x. Okay? Now be careful. This is an odd root. All right? So the odd root, so let's say this is the fifth root of 2 times 2 is 4. I'm trying to figure out, let's see, the fifth root of, let's say, negative 32. What's the fifth root of negative 32? What times itself 5 times the negative 32? Why, negative 2, right? Okay, so the odd root of a negative number is always negative. The odd root of a negative number is negative. So remember, so the odd root of a negative number is negative. So that means that the fifth root of a negative x means the same thing as negative fifth root of x. Okay? That is the same thing as this. So that means I can write this as 7 times a negative fifth root of x, which becomes negative 7 fifth root of x. So I found f of negative x. Now, let's compare this with this. Do y'all agree that these two are not the same, right? You can see it. One's positive, one's negative 7, right? So are they opposites? Yes. Because if I look at this right here, do y'all agree if I cover the negative that this is f of x? And so if I bring the negative down, that means the opposite. So f of negative x is the opposite of f of x. So that means that this function is what kind of function? If they're opposites, if f of negative x is the opposite of f of x, that means that this is what kind of function? an odd function. So f of negative x is an odd function. Okay? All right, and then number 9, let's suppose number 9 we had this. F of x is equal to, let's say, negative 4x to the 4th plus 7x minus 2. So negative 4x to the 4th plus 7x minus 2. So I want to know, is this going to be an even function, odd function, or neither? So we got to find f of negative x, always. Always. So where we see the variable x, I see it twice, I'm going to substitute negative x. So I get negative 4 times negative x to the 4th plus 7 times negative x minus 2, right? Well, remember, negative x to the 4th means x to the 4th. So remember, negative x to the 4th means x to the 4th. So this becomes negative 4x to the 4th. A positive 7 times a negative x is a negative 7x minus 2. All right? Now here's the question. Is this the same as this? Does that look exactly like this? No. The x to the 4ths are, the constants are, but the problem is this, right? Okay. So here's my question. Is f of negative x the same as f of x? The answer is no. Okay? So here's how you see this. Here is f of negative x right here. And you're asking, is this the same as f of x, which is this? The answer is no, because of this. Okay? So here's the next question. Is f of negative x the opposite of f of x? You may say, well, I think so. And then some of them may say, well, no, I don't think it is. All right, well, here's what I would do if you're a little confused. I would go ahead and write f of x first. Here's f of x, right? Okay, so let's write it. So for that in parentheses, negative 4x to the 4th plus 7x minus 2. If they were opposites, I'm going to rewrite this now. If they were opposites and I distribute, okay, let's see what we get. Do we get this back? So I get 4x to the 4th minus 7x plus 2. So is this the same as this? No. All right, so f of x is, so this is not odd either, right? Not odd. So it's not even, it's not odd. So we say f of x is neither. Okay, so it's not the graph, so meaning that the graph is not symmetric about the y-axis or origin. That's what that means. Okay? All right, so most students, a lot of students do have difficulty doing algebraically what we did. All right, so what I suggest you do is go back over the same problems and see if you can just do this by yourself without looking at what we did. All right, so a lot of students do have trouble with this. Students can easily determine if by the graph if a function is even, odd, or neither. They can easily do that. It's algebraically that they sometimes have trouble with it. Some of this is easy for students. Some of this is not. Like maybe this one may not be as easy. This probably you would have had difficulty at first because you probably did not remember that the fifth root of a negative x is the same as negative fifth root of x. So there are some things you got to remember from previous courses, some prior knowledge to get through this. But that is the lesson on determining algebraically if a function is even, odd, or neither.